All right, let's do this. 4 constructions involving circles. And you know how I do it in honors. I just don't want to tell you the steps. I want to use some circle facts to show you why it works. So the first one here is, how do I construct a tangent line? Remind me again so I know what we're constructing. Tangent, line that intersects one spot only. And that point in this case is going to be point P. So I want a line tangent to this circle, but it's got to go through P. First step, grab your straight edge, everyone, whatever you're using as a straight edge. And can you give me an extended radius through P? An extended radius through P. Compass. We are going to use a circle fact you're aware of already to do this construction. When the tangent is finally done, when we're finally done with this construction, what are you going to know about this radius and that tangent? They should be perpendicular. So that's exactly what I'm going to have you do, is make a line that's perpendicular to your radius, but going through P. That's guaranteed to be a tangent then. Again, we're going to make a line perpendicular to your radius going through P. We had done this already this year. We had done this. We've done a, hey, here's a line, here's a point on it, draw me a line, a perpendicular line through it. Ready for the review? Slap that compass point on point P. And it has been about a month or 2 since we've done constructions. Remember, please don't make these huge arc marks, because what's going to happen at the end? You have all these arc marks flying around and you don't know which ones to connect. So please try to make them small. Make an arc that intersects your extended radius in 2 spots. You can do this above or below the line. So an arc coming from point P that intersects your extended radius in 2 spots. And mark those 2 spots, please, with points, because that's where you're going to put your compass the next 2 steps. You guys remember, most of these constructions I've been showing you, the first arc is always just to establish points of intersection to put my compass. Everyone's got 2 points? All right, that's where your compass is going to go the next 2. And look at you guys. I don't even need to say much, do I? Jeez, you guys are moving right along. Put your compass on one point of intersection and make an arc. Does not have to be a huge arc. Go to the other point of intersection. So the arcs you make from the points of intersection should intersect each other. Those arcs should intersect from those points. Is anybody having it cross right on point P? Or is it separate? I want to make sure we're good, because I have a solution for that. Is everyone getting 2 arcs that intersect that aren't right on top of point P? We're all good there? Okay, make your tangent. Here you go. You're making a perpendicular line and a tangent line at the same time here. It's guaranteed to be it's perpendicular, because that's what the construction we did. And the only time it's perpendicular is if that's a tangent. All right, so that is how we get to construct a tangent line. Still using our facts. All right, any questions on how to do the tangent? You good over there, Matt? Talk to me. What do you got?
Wait, can we just do it again?
All right, what extended radius?
Yeah, I got that.
Okay, compass point on P. Make an arc that intersects your extended radius in 2 spots. Good?
Yeah.
Or-
I know.
I can go, Matt, we got plenty of time today. You good? Or you want me to keep going?
I'm good.
Okay, or is it more the handler of the compass?
I'm good.
Okay, let me know. All right, next up, inscribe square. Time to make a square in the circle. Real quick, I want to know from people why something that looks like that won't cut it. It's a square inside the circle. What's inscribe mean again? These 4 vertices have to touch the circle. All right. I want to talk this one out before we put compass to paper. All right, I'm good enough. There we go. All right, let's talk this through before we do anything with the compass. First thing I say, hey, properties of a square. What's probably the first thing all of you say?
Same side.
We're talking a square.
Right angles.
I wouldn't. You probably wouldn't say that first.
Sides equal.
All four sides equal. That's probably what we say first, right? All four sides equal. All right. Can you not call them sides because we're in a circle now? So those would be four congruent chords, right? Those are chords. So you would have four congruent chords, and you know from this unit, the chords would be congruent if the what are congruent? Arcs. There we go. So here's what I'm asking from you. Four congruent arcs. Four congruent arcs, which means, keep going with me now. What do they all have to measure then? If I need four congruent arcs, they all have to have a measure of 90 degrees. Okay, so that's what I'm looking for you here. If you can get me four 90-degree measured arcs, I think I can do a square. Whoa! All right, how are you going to get me four congruent arcs then that each measure 90? Maybe I'm asking a little too much. So let me take four and knock it down. Can you get me two congruent arcs? Better. How can you get me two congruent arcs here? See? Pick up a straight edge and draw a diameter. Don't say any more. Right? Everyone agree? Draw a diameter. You'll have two congruent arcs. There you go. There's two. And what do these two measure? 180, but we're looking for what? For that measure? Going from 180 to 90. 180 to 90. Looking for a vocab word. 180, bisect. Correct. Not bisect the arc, but we're going to bisect the diameter. All right, we're going to have a perpendicular bisector for the diameter. Ooh, remember how to do that one before I review it? This is the one all of you probably know or remember. How do you do a perpendicular bisector for a segment? Put your compass point on an endpoint and go more than half. Good. We want to make a decent size arc because I need 2 points of intersection here. So make a decent size arc for me. And go over the other end point of the diameter and do it again. 2 points, not one, 2 points. And draw in your perpendicular bisector, which is also another diameter. Hopefully when you're drawing this in, it goes through point T. Hopefully when you draw this other diameter in, it's going through point T. This is so much fun for me just because I get to spit out all these circle facts. Guarantee me those are 90 degrees. All right, we just did perpendicular bisector, right? So I understand where the right angle comes from, but guarantee me those arcs are 90 now. Why are those arcs 90 then? I know that angle's 90. I get it because we did a perpendicular bisector. But why now the arcs, Doyle? All right. They're all central angles, and central angles always equal their arc measure. What do you need, Steve?
Why do you need 2 points intersect in case T is one of them? Because it's at the midpoint of.
Okay, if you have usually yes. In this case, yes. Usually though, we don't have that point T when we're doing a perpendicular bisector of a segment, but it is a good check.
If you don't have point T, how would you do the first one?
Say that again. You need this. You need the center. Yeah, you need the center of the circle to do it. Yeah, there's no other way because you don't know you're going to draw in a diameter or just a regular chord. All right. Is anybody seeing how the square is going to get made now? Because we needed chords, right? There you go. Let's get from those arcs, draw in your congruent chords. Look at you guys, got a square. I want to keep going here with this one, though. I want to keep going. I got another circle question for you. Get that square drawn. First thing I asked you, what's the most commonly used property that students are going to give me on a square? And yep, all four sides are equal. And we've proven that now because congruent arcs have congruent chords. Ian, you gave me the second one usually kids say, which is what?
4 right angles.
4 right angles. Hey, another question for you, honors kids. Guarantee me that that's a right angle.
It's drawn to the diameter.
What is? It's an inscribed angle drawn to a diameter. Got to be a right angle. Same with these three as well. God, look how it all comes to play. Anybody thinking this is a thing of beauty other than me? Probably not. Okay, so I'll just celebrate within myself. Good. Questions? Square. You ready to up it a little bit now? Hexagon. And I want you guys to use the same thinking we just did for a square. But now how many sides do I have? 6. Real quick review. Regular, it's got to be, all of those sides have to be congruent. Yep. So think about it. All right, I need 6 congruent sides. And again, what are those sides going to be in the circle? What are those sides going to be in the circle? Chords, right? So I need 6 congruent chords, which means I'm going to need 6 congruent arcs. Right? 6 congruent arcs. And I don't expect you, and I'm not going to give you 5 minutes to think about it or anything. I'm going to show you how to get 6 congruent arcs. Step number 1, draw a radius. Not an extended radius, just a radius in, please. Grab your straight edge, draw a radius in. I can't get it to not extend. I've been trying this all day. All right, I'm done.
Not that hard to draw a line.
I'm good. Nobody can see it's extended anymore.
It's just a sloppy line.
No, it's fine. A lot of criticism in this class lately, huh? All right, here we go. Using your compass, measure your radius, please. Measure how long it is using your compass. Take your compass, open it up to the length of your radius. Let me tell you what we're going to do before we do it. We are going to make arcs that are the same length as your radius. We're going to go around the circle right now and make arcs that are the same length as your radius. So start with your compass point on where your radius intersected your circle. And here we go. Let's make our first arc that's the same length as our radius. Ready? Boom. There's one arc. Let's keep going around. Remember, we need how many congruent arcs? 6, right? All right, so make sure we have 6 arcs that are the length of our radius. So I have 1, 2, 3, 4, and here come 5, 6. And then we draw our chords from those arc marks that will form an inscribed hexagon. Any questions? Square, hexagon? And why don't we do another figure while we're here, huh? Equilateral triangle. One of the few things that I do like about this class is that you guys are very clever. All right, you're very clever. Annoying most times, but clever, yes, as well. So I think you'll be able to get this. I don't want to say anything about this on how to do this construction. Equilateral triangle. What's going through your mind?
Equal matter.
Equilateral triangle. What's going through your mind?
2 in a circle. Like if you just cut the square, once you get 2 circles. Or I mean 2 triangles. They're the same.
Equilateral, though, would have a would.
Oh yeah.
What's equilateral? I'm just starting with basic equilateral. Doyle?
3 sides.
3 sides congruent. What have we talked about? That means 3 chords congruent. That means what? 3 arcs congruent. You know how to do 2. You know how to do 4. You know how to do 6 now. Now I'm looking for 3 congruent arcs. So I can draw this equilateral triangle.
It's like an axial.
We already did it. We already did it. I already taught you how to make 3 arcs. No, you didn't. That's 6 arcs up there. I know. Could you get 3 from that, though? Good talk. So let's do it. I'll just let you guys do your thing. Yes, it's the hexagon construction. It is the hexagon construction. Yes, when you do the hexagon construction, you make 6 60-degree arcs. So if you wanted 3 arcs that are congruent, you connect, yes, every other one to make 120. There you go. Good job. So maybe we did 4 constructions today, but it was really 3. Okay, because hexagon and equilateral triangle are the same ones. So here's what I'd like you to do. You'll be able to finish up the next 2 constructions, which is the assignment tonight. Don't pack up, please. Go right to review for quiz 3 and start reviewing for quiz 3 with those problems. All right. So try out those 2 circle constructions on your own to practice, and then go right to review for quiz 3.